So we are finding domain and asymptotes. You have to know all of your asymptote rules. So let's kind of refresh. How do we find the domain?
What makes the numerator 0?
That's an x-intercept.
Oh, yeah, that's the, yeah.
Basically, article,
Yeah, so basically in the domain, the denominator can't be 0. And those numbers that aren't in your domain are your vertical asymptotes. So in the vertical asymptote, it's when your denominator does equal 0. Okay? These will always be x equals a number. So your domain, you're taking those numbers out. Those same breaks in your domain are where we get vertical asymptotes. Then horizontal asymptotes and oblique asymptotes all depend on the degree. If the degree of the numerator is less than the degree of the denominator, what does that mean?
it's equal to 0.
It's a horizontal asymptote, y equals 0. If the degree of the numerator equals the degree of the denominator, what does that mean?
You divide the first two numbers.
You'll get y equals some number. It's a ratio of the leading coefficients. Okay, if the degree of the numerator is 1 bigger than the degree of the denominator, what does that mean? It's not horizontal. It is an oblique. And that would be a line. Y equals mx plus b. We have to do long division to get that. If it's more than 1 bigger, what does that mean?
There's no horizontal.
No horizontal or oblique asymptotes. So, when we look at this one, for the domain, we said the denominator cannot be 0. So x cubed cannot be 1. So cube root, since it's an odd root, you don't do plus or minus, so x can't be 1. So how do we write that in interval notation?
-3 to 1 union 1 to infinity.
All right. Vertical asymptote is x equals whatever makes the bottom 0. And we've already found that. It is 1. Then we look at horizontal or oblique. What is the degree of the top? The bottom.
3.
So if the top is bigger by 1, it's oblique. If it's more than 1, what does that mean?
There's no horizontal or oblique.
Is it possible to have both horizontal and oblique? No. It's one or the other and possibly neither one. Okay, other questions on the front page? All right, second page, what do we have? Apparently an unnumbered question right there to start the page.
I did struggle a little bit on 3A, so I guess
Okay.
I'd like to check that.
Let's take a look. All right, so part A, or the first thing it said, was factor the numerator and denominator. So numerator, multiply to 9 and add to -6.
-3.
And x squared, I mean, you could write it as x times x, but it's not really necessary. So second thing, x and y intercepts. How do we find an x-intercept?
Set the top equal to
So
0.
top equal to 0. X-intercept is where you hit the x-axis. So y is 0. So it's like if you set this entire equation equal to 0 and solve it. And so we just get 3. Your y-intercept, how do we find that?
By setting everything equal to 0.
Setting all of your x's to 0. Okay, because where you hit the y-axis, that means x is 0. If you put in 0 for all of these x's, what do we get?
No solution.
At the top would give us 9. The bottom would give us 0, and we can't do that, so we'd say there is none. All right. Then, next thing, I asked for asymptotes. Vertical asymptote, x equals, what makes the bottom 0?
0.
Horizontal or oblique, what is the degree of the top?
2.
And the bottom?
2.
If it's the same degree, it's horizontal, and we find it by dividing the leading coefficients. So 1x squared over 1x squared is 1. So then, we need a graph, and we put all the stuff on our graph. So if you found it, I expect you to plot it. We have an x-intercept at 3, no y-intercept, vertical at 0, horizontal at 1. And then what do we do? Graph it. Make sure when you graph it, you are putting parentheses around top and bottom, or you can use that fraction feature we talked about if that helps you to kind of see what you have. You do alpha to y equals, that would bring up your fraction if you like doing it that way. Either one is fine. So if I graph this, x squared and your graph should match the stuff we have. Now, you'll notice this graph does look a little bit weird. This section is like here. What's happening here, I've told you, you can cross a horizontal asymptote. It's what happens as we go off forever. So it's going to cross that, dip down and hit our intercept, and then it's getting closer from underneath. Questions on that one? All right, what else on this page? Several of you said you were having a little bit of trouble with the graph, so we probably need to talk about them. B. Good. All right, so first is factor the numerator and denominator. So on the top, we could take out an x. Bottom, we can't really do anything. Second step, x and y intercepts. X-intercept when y is 0, or when the top of the fraction equals 0. So that happens at
0 and 2. Wait.
Yeah, 0 and negative 1/2 if you work it out. Okay, y-intercept, if you put in 0 for all of your x's, you get 0 divided by negative 1, which is 0. Asymptotes, vertical asymptote, x equals, what makes the bottom 0? 1. What's the degree of the top? Bottom. If the top is 1 bigger, what does that mean? Oblique. To find it, we have to do long division. So we have a 2x squared plus x divided by x minus 1. 2x squared divided by x. What's that equal? 2x. So that's where we start. Then you multiply. You have to take the 2x times your x minus 1. So we get 2x squared minus 2x. Change our signs. So those cancel. This would be a 3x. And we don't have anything else to bring down. So then we're back to dividing. What is 3x divided by x?
3.
And that is all you need. So your oblique asymptote y equals 2x plus 3.
I think my calculator is weird.
Plot your asymptotes and intercepts. Okay, y equals 2x plus 3. So that's just a line. Y-intercept is 3, slope is 2, so up 2 over 1, or we could say down 2 and back 1. Okay, now remember, we've talked about how your graph has to exist on both sides of your asymptotes. So you might have to zoom out or something if you can't see everything. So if I want to graph this, we have 2x squared plus x on top. And x minus 1 on the bottom. Okay, am I seeing everything right now? But I know that can't be the only piece because there has to be something on the other side of my vertical asymptote. So if you just zoom out, anytime that happens, then we can see the other piece up there. So this one, it is not flat in between those. That would make every point an x-intercept. So you have to make sure that you are drawing it accordingly, and then we have another little piece up here. Does everybody see that? Anything else on this page? Do we want to look at more of these graphs? What about C? That one has an extra little twist to it. Let's take a look at that one. Okay, so factor. The top, we can do slip and slide. So that factors into x minus 8, x plus 1, by 2. And then the bottom we factor into x minus 4, x plus 3. What do we see here? So, when something cancels, remember that gives us a hole in our graph. So the polynomial, or the rational function that we're going to look at is the reduced one. But when that cancels, we know there is a hole. The x value is from the x minus 4. What makes x minus 4 equal 0?
4.
Then to get the y, you plug 4 into what's left. So 2 times 4 plus 1 will be 9. 4 plus 3 is 7. Does everyone understand how we get the location of that hole? Next step. So x-intercept, what makes the top 0? Mhm. Y-intercept, if you plug in 0 for all of your x's, again, we can just do it right here, we get 1/3. Vertical asymptote, that is based off the reduced one, not the original. So if we look at our reduced one, what makes the bottom 0? So vertical asymptote x equals -3. Okay, do we have horizontal or oblique? So we look back at the degree, you can do the original or the reduced, it doesn't matter. The original, what was the degree of the top?
2.
Bottom?
2.
If it's the same degree, that's horizontal. You divide leading coefficients. So 2x squared over x squared is 2. Asymptotes are lines, so you have to give a full equation when you do those. Is everybody okay with that? Okay, we have a whole, we mark that with an open circle. Positive 4, 9/7, which is a little past 1. We have a horizontal asymptote at 2. And vertical at -3. Okay, then we plot our intercepts. We hit the x-axis at -1/2. The y-axis at 1/3. And then you graph it. Always go back to your original. We had 2x squared minus 7x minus 4 over x squared minus x minus 1. Okay, so we can kind of see what it looks like when you're drawing this. Make sure they are curves. Getting closer to your asymptotes, you need to go through your intercepts that you marked. And this hole is just a point on the graph. Make sure you don't accidentally fill it in as you're going through. Any questions? Do we need to look at anything else on this page? What about the next page? E and F are more graphing ones. We can look at those. Your equations. For A is no solution, B is -1, C is -2, and D is 1/4 and -1. What do you want me to work out on this?
Your study guide has a few extra problems.
Did I have more on this one?
Yeah, I don't think we have your D, and we don't have J.
All right, so we have 10 over 3 plus 2x is less than or equal to 5. So with equations, our goal is to basically get rid of the fraction, and we can do that by multiplying. This isn't an equation. Why can't I multiply by the 3 plus 2x?
Because you have to get everything on the same side.
With inequalities, if you multiply by a negative, it flips our sign, and we have no way of knowing if that's positive or negative. So instead, get everything on one side and do our 0 on the other. This is like a 5/1. So if we want to put those together, we need a common denominator. So we're going to take this times 3 plus 2x on top and bottom. Because it's a subtraction, make sure plus distribute that negative. So positive 10 and negative 15 will give me a negative 5 minus 10x over 3 plus 2x. Now what do we do?
Sine line.
So if we set top and bottom equal to 0, we get negative 1/2 and negative 3/2. So those are test points, but make sure you're putting the smaller one first. Smaller than negative 3/2, so maybe negative 2. In between them, maybe negative 1. Bigger, maybe 0. You are taking those numbers and plugging them into this fraction. Okay, so if we put in a negative 2, on the top we'd have negative 5 plus 20, so that's positive. On the bottom, 3 minus 4 is negative, so that section turns out negative. If we put in a negative 1, on the top we'd have negative 5 plus 10, which is positive. Bottom, 3 minus 2 is positive, so that section is positive. If we put in a 0, we'd have negative 5 on top and 3 on the bottom, so negative over positive is negative. Which answers did we want? Negative. Equal to means bracket, but the negative 3/2 cannot have a bracket because it makes the denominator 0. So it's negative infinity to negative 3/2 with the parenthesis, union bracket, negative 1/2 to positive infinity.
On 3E, it's one of the graph ones, does the negative affect anything?
No, it will affect, like when you put the graph in the calculator, it flips it, but it doesn't impact any of the work you do. Anything else you want to work on here? Yes, 4D. Okay, so on the equations, our strategy was to multiply and get rid of them, but we had to make a note. What can x not be? And that's because those make the denominator 0. So if we want to get rid of the first denominator, we have to multiply by x plus 8. And if you do it to 1, you do it to all. That cancels this. We still have an x minus 8 on the bottom. So now everything gets multiplied with x minus 8. And that includes the negative 1. And those are gone. So we are left with 6 times x minus 8 plus 6 times x plus 8 equals negative 1 times, if you multiply those, x squared minus 64. Okay, multiply everything out. Set it equal to 0, so if you add over your x squared, 6x plus 6x is 12x. Negative 48 and positive 48 cancel, bring over 64. What multiplies to negative 64 and adds to positive 12? So we get negative 16 and positive 4. Are both of those answers okay? Yes, the only thing we couldn't have is positive or negative 8. So that works. Anything else?